Okay. So we are half done with Berezin integral. I guess half done. So I need to start with some reminders, I guess. So what is our setup? We have phi, which is isomorphism from UMN to VMN. So isomorphism. And so on UMN we have coordinates x and theta. On V we have coordinates y's and xi's with corresponding indexes. And we have these functions f's which are pullbacks of y's, and we have functions g which are pullbacks of xi's. And we have Jacobi matrix, which is this written in this block form: negative df over d theta, dg over dx, and dg over d theta. And then theorem says that if I have so int over some function h, d xi dy d xi over v. Maybe I have to put here vmn is the same as integral. And well, here h is a function, so it's a section on v, right? So cmn infinity v, right? But also, well, should be with compact support. And we figured that it means that not only coefficients, so it means something for all the coefficients in front of all polynomials in theta in H, well, in Xi in this case. And so I need to pull back, change variable, so to say, in H. And then I need to include Berezinian of j phi. And here I have to write dx d theta. So we were proving this, and so we said that it's enough to prove in the following two cases. First case we did prove, and this is when f1 is just x1 plus some gamma, where gamma is in j squared, and everything else is just, so fi is xi if I is greater than or equal than 2, and gj is just theta j for all j from 1 to n. So this one is done, and this one is And the second case is when I change just one of g's. So I have g, well, without loss of generality, the first one. So g1, sorry, not this one we did, but the second one, okay. So g1 is theta 1 plus some eta, where eta is inside J3, and then I have fi equals to xi for all I from 1 to m, and gj equals to theta j for all j except the first one. So I think I did something stupid when I was proving that it's enough to prove this, in the sense that, well, I precomposed it with a. So okay, let me we discussed it at the after official end of the class. So let me actually indicate this now. So what was the reasoning? I want really, so I constructed some map psi from UMN, well, with some prime, U prime MN to U MN. Right, so suppose that I have phi, right, and well, phi was phi is our original map, and also I would wanted to precompose it with certain psi. Psi I defined like this. So here, well, I defined by pullbacks. So psi star of xi. So this part was little bit not good. So, but just a reminder, it was something like this, and psi star of theta was well, b sum over bij inverse x. Well, theta j, right? And here I need primes, I think. Yeah, so where this so this depends on x, this dependent on nothing. So actually this is wrong. I want to correct this. So first of all, just a reminder, what was this a and b? We actually had so they just came from the following thing, how to write it better. Well, I just consider differential of phi, and this has like a block diagonal form. And actually here I had a, well, of x, and here b of x. And so this was, so a without x is just aij of corresponding to what? To 0 in my case. But this is not what I want anyways. I really want this to be so correction. I need psi star of xi to be phi tilde inverse right of x prime, so to say. All right. Well, yes. Well, So okay, here I have I, and well, phi, well, ith coordinate, ith coordinate. But what does it? So sorry, let me see. So phi tilde is a map. Сейчас, а что значит какие-то координаты? Это правда, да. Ну правильно, да, все правильно, да, все правильно, да. Так и есть, да. Вот. Ну, здесь тоже, это тоже какой-то под, this is also some open neighborhood of Rm, right? Well, this is some function, so I write down in this coordinates x prime. So that's what I'm doing. Right, and because if I do this, then actually if I compose, so then if I compose psi phi with psi, right, and this was like my phi tilde. Then, well, phi tilde was almost of the form that we need. We just, well, we had this change, but, well, this form of change, but for all the coordinates, right? So phi tilde was acting on y I. Well, phi tilde star. Well, phi tilde is not very good. Let's denote it somehow. Because tilde is reserved for something else. I don't know. What was the notation last time? I think I changed it to something. Phi tilde, yes. This is not very good. But okay, let's change it to some other letter. Maybe это. Это тоже нехорошо, да. Окей. Yeah, we kind of exhausted all the letters. Then maybe let it be just phi bar, whatever. Okay, and then okay, so I'm spending too much time on that, but idea is that, so I wanted just to discuss this correction. So then indeed hopefully I get what I need. Pull back with respect to this phi bar is xi prime up to some gamma I, which lives inside j, so to say j prime squared. Right, j prime is the ideal which is generated by theta primes. And phi bar star of xi, xi j is actually theta j bar plus some eta j, and this eta j is from j prime cube. All right. So then we discussed that I can split my phi bar into sequences of transformations of such form, and then I need to prove, well, since Jacobian matrix is multiplicative, if I compose my transformations, then it means it corresponds to multiplication of Jacobi matrices. Then it's enough to prove just in these two cases. So I think this one we proved. Now let's prove the first one. So the first one. Right, in this case, so I have this gamma, right? So proof in case 1. So I claim that in this case, my J phi looks as follows. So I have ones here, right? And then I have 1 plus gamma here. Well, 1 plus gamma prime, where gamma prime is d gamma over dx1. Right? And then I have ones here. Then also I could have some well, I have something in here, right? And I guess what I need is zeros everywhere here. And dg over d thetas is 0. Yes, so g doesn't, so dg over the d thetas, sorry, it's ones over with respect to x is zeros, and df with respect to thetas might be something because of this gamma, right? Well, actually everything stays in this first line, all these stars, right? Anyways, Berzenian of this is 1 plus gamma prime. Just this one. Easy as that. Then I compute. So I claim that it is enough to prove the following statement. For any h from C infinity mnv, integral h x1 plus gamma 1 and then x2 blah 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 xn 1 plus gamma prime dx. So this is just the usual integral with respect to v. Right, with respect to u. Right? So here I have u mn equals to integral h of x dx with respect to well, just this one. Well, with yes, well, in this case u and v, they are just equal because of our change. With just well, u and v are equal because, well, tilde is just identity in this case, right? And so in this case, just u here again. This is one thing. Another thing why I claim that it's enough to prove such thing, to prove the theorem. In this case, well, let me maybe say that then, like, if I denote this by star, right, then if I just sum this up over, so if I so I have h over there and h over here, which is unfortunate because so let me think, what do I want to do with notations? Yeah, so let me change this one to something else. Sorry. What letters do I have also? Maybe just A. Would it be okay? For any A from this one. Because then I do what? So I have my H. This is the function from the theorem. And I'm saying that, okay, let me take star and sum. So then I instead of A, I put components of H, right? So my H is HI Xi I, right? Sum over I. Right, so I take sum over I of this equality. So this is like a schematic explanation of both sides, where I put A equals HI. And then, well, I put A equals HI and then take like a component corresponding to the full to the full I, right? To full subset I. So I'm just, if I prove this, then well, I have I can replace A with coefficients. Coefficients. So actually here I don't even need A to be from this one. I need A to be from just this thing. Okay, because each coefficient of H is inside here. Right? And we said it's V and U is the same thing. Что написано? Правильно. Написано следующее. Давайте, смотрите, если мы докажем вот это, я утверждаю, что тогда мы докажем теорему для случая 1. Почему? Ну, здесь я любую функцию могу подставить. Давайте я буду подставлять функции вот эти, h и t. Вот, ну, в принципе, для всех i. Вот. И у меня как бы сразу будет, ну, несколько сразу тождеств. Один плюс гамма штрих, оно влияет сейчас. Правильно, то есть вот здесь вот надо на самом деле кси и еще написать, да? Вот так вот, да. Ну, в данном случае, да. Да. Ну, да. Вот. И я получил действительно ну, несколько тоджес, я их сложил. Вот. И посмотрел, ну, действительно, вот как посмотрел на то, значит, домножил на такие ксииты, да, сложил и, значит, посмотрел на слагаемое при n. Не, ну как, 1 плюс гамма штрих у меня уже есть, как бы. Ну, он у меня как бы и есть. Ну, это я использую, что у меня вот звездочкой. Не, звездочка это вообще вот просто вот это тождество. Как бы я тождество могу складывать же. Да, сейчас, давайте разберемся. Значит, мне нужно показать вот такое. Ну, вообще говоря, я сюда должен подставить мою функцию h. Ну, хорошо, давайте аккуратнее. Ну, это правда. Не, хорошо, давайте аккуратнее. Значит, давайте посмотрим. Значит, давайте сюда пойду. А может быть, у меня не получилось здесь, значит, сказать, как надо. Значит, я хочу чего? Я хочу, что... Давайте вот прямо ту h возьмем, да? У меня есть h, правильно? Ну, я как бы ну, в каждом h-итом, да, у меня должно быть x1 плюс гамма-1, да, x2 и так далее, xn, правильно? Затем единичка плюс гамма-штрих, так. И потом dx, d тета. И еще, ну, тета и т. Значит, и сумма по и, ну, неважно, давайте вот здесь. Вот. И я хочу, чтобы вот это равнялось, значит, интегралу по моему умн, ну и там и сям, умн, h, ну как бы сумма по и, h, и, t, тета, и, t. Ну, в данном, здесь, ну, понятно, что я должен, ну, это просто будет интеграл по u, h, nt от x dx, правильно? А здесь, ну, сейчас, ну, значит, значит, у меня чего-то будет от гаммы штрих, но гамма штрих, значит, у меня из нет, ну сейчас, а как я это? Это, наверное, все-таки я не могу к такому свести, да? Ну ладно. Сейчас, ну здесь, ну хорошо, то есть, а так это будет, я должен, значит, что-то сделать, и у меня будет, вообще-то говоря, зависимость от тета, непонятно из какого как бы слагаемого она вылезет, да? Сейчас. Сейчас, одну секунду. Нет, ну сейчас. А все-таки почему вот это... Ну, в принципе, я интеграл, я тут могу перенести, да? Ну вот так вот написать. Наверное, не важно. Это можно, хорошо. Потом, значит, но это все равно, что, значит, интеграл, но это все равно, что интеграл по u вот этого h-итого, да, опять от x1 плюс гамма и все остальное, единичка плюс гамма штрих на тета и да. Что? Ну, в принципе, да. В принципе, да. Ну, хорошо, давайте тогда попробуем. То есть вот у меня, в принципе, тогда, значит, интеграл по u. Ну, понятно, что вот это какая-то, ну, это какая-то... Сейчас, ну, единственное, что... Сейчас, давайте все-таки я попробую. Если я так сделаю, ну, вот это то же самое тогда, что интеграл... Вот здесь вот может быть проблема, да, получается, что от h и t... Ну да, то есть я вот не могу вот так вот переписать, что это интеграл h и t x1 плюс гамма, единичка плюс гамма штрих dx, ну и как бы, и вот здесь вот так взять скобочку и помножить как бы на тета и t. Ну, в том смысле, что не могу взять вот как бы вот так, да, и потом посмотреть от этого n-t слагаемое, да? Вот в этом ошибка. Угу. Сейчас, а почему? А мне кажется, что правда, что это равно. Не, ну это же просто интеграл по x. Ну как, что я делаю? Якобы здесь вот я делаю какую-то вот ерунду свою суперсимметричную. Да, то есть это будет какой-то там типа тоже сумма какая-то с какими-то коэффициентами. Да, вот этот интеграл по x значит, что я по каждому коэффициенту там интегрирую. Ну это ладно, вот. Теперь, ну я должен посмотреть на то, что вот здесь вот вылезает и добавляется вот этим до n-того, взять соответствующий коэффициент и проинтегрировать. Вот, поэтому вроде бы, если я как бы напишу такое, то это правда. А поэтому то, что я здесь написал, и это прям то, что я делаю. То есть у меня есть вот такой интеграл. Я его домножаю до тета-итого. Да, это левая часть вот этого равенства, когда я взял h и. Потом суммирую все по i. Это я все могу делать с равенствами. И потом беру и вычисляю, значит, n-ый коэффициент. Потому что вроде бы все-таки, наверное, правда. Вот. Значит, тогда вот это теорема. Все, ну давайте тогда вот это. So let's prove star. So to prove star, so I have left hand side of star equals. Well, then I need a definition of what's going on here. So it's sum. So we have like a formal Taylor series over r greater or equal than 0, 1 over r factorial. Yes, by the way, Sergey was, or somebody, maybe Pavel, was talking. So if you remember the discussion about what about definition of this thing, right? It was through Taylor series, and actually somebody noted that maybe I need to add factorials. And then I thought a little bit that maybe not, because well, all the factorials will be 1. This is not true. So actually I need to add factorials there. So that just came to my mind because well, I have 1 of our factorials still here. All right. Integral h. Well, I take rth derivative with respect to well x1 of x. Well, now, sorry, I said that it should be a. So let's keep it this way. Right. Okay. So this was. And then. So again, so what I'm saying is that AR is just D A dRA over dx1 to the power r. So that's derivative with respect to the first one, the first variable. Integral of this times gamma r 1 plus gamma prime. This just comes from 1 gamma plus gamma prime there, dx. And so just that. This equals to integral. So I have 0th term here, which is just what? Well, I have 0th term and without this one. So it's just integral a of x dx. Plus, I have sum over r greater or equal than 0 of such thing 1 over r plus 1 factorial h again a r plus 1 gamma r plus 1 plus r plus 1 right. So this is like that times h r gamma r gamma prime. So So I'm kind of changing indexation a little bit. So this term I'm putting into the previous index. And so, and then the term with r equals to 0 corresponding to this one without this term, I just separate. So maybe I also have to write integral somewhere here and dx. Okay. But this guy is actually a derivative of something, right? It is actually derivative of h r gamma r plus 1 prime. Right? And I integrate over something which is derivative. We have no... да, извиняюсь. Это я, значит, перестроился со своих записок. Сместился, да, потому что там было f, оно стало h, а здесь было h. Теперь нужно было что-то другое, вот a. Да, производная только по x1. Ну, значит, это производная только по x1, это правда. Значит, но утверждение, что на самом деле можно перейти просто, ну, от других переменных чуть-чуть, ну, более-менее ничего не зависит. Значит, сейчас сформулирую правильно. Значит, не, ну в любом случае это какой-то многомерный интеграл. Правильно? Ну, я могу сначала проинтегрировать по dx, а потом проинтегрировать по всем остальным. Вот. Ну и как бы я везде так и делаю. Вот. И когда я интегрирую здесь по dx, ну, то есть у меня никаких границ нету, ничего, то есть вот это 0 просто. Вот. И поэтому остается от x dx, и мы все доказали. Right. So actually, the theorem is proved. Okay. Okay. So now, well, we can, if we had more time, we could dive deeper into, like, maybe, well, formulate. Well, at least so this is global, right? This is a local situation, right? So it would be an interesting thing to see how to integrate globally. So maybe let's formulate it now. So in general, suppose that I have M super manifold. I have more than one chart on it. Well, I need some kind of orientation on M. So let us fix this one. Actually, there are 4 orientations on supermanifold because, well, differential consists of 2 blocks. So you can, you know, have, well, you can require one block consistent, this block consistent on both of them, right? So then, so actually there are, you know, 4 choices of signs of this, of determinants of these blocks. That's what I mean. So anyways, this discussion is a little bit out of scope of what I wanted to say. We need to choose one of these 4 options, and we choose the following: orientable. If so we say we call M orientable if there exists well, super atlas, right? U alpha phi alpha on M, such that the corresponding transition maps, if I take, is there, so these are morphisms of supermanifolds, right? And well, I can take phi alpha inverse phi beta on intersection, on some intersection, and this will be again in the block form, right? So maybe yes. So this one I will just denote dx phi alpha beta alpha 0, and this one is phi beta alpha 1. So such that determinant of dx phi alpha beta alpha 0 is greater than 0, where this is explanation what is d phi alpha beta alpha is 0 is. So anyways, we say that M is orientable. If it's an orientable, it's a usual differential manifold. Okay, it has a usual differential manifold structure. So if it's orientable there, then we say that it's orientable. Sometimes it's called, sometimes this is called 1-0 orientable. So there are other choices, like for example, 1-1 orientable is that determinant of this and determinant of this are greater than 0, or 0-1. So, but in our case, orientable by default means it's 1-0. All right. This being said, suppose that choice of such atlas gives us a choice of orientation then. Well, actually, well, you can define, you know, equivalence classes of bases and all that. And so this is as usual, no surprises here. So orientation is a choice of equivalence class of such atlases. So suppose that M orientable. Okay, so maybe this I will formulate as definition. So suppose M is orientable. Choose orientation. Meaning that we choose some atlas which possess such property. So let U alpha phi alpha the corresponding atlas. So my goal is to formulate what I want to integrate over. So what are these things? Let's call them volume forms. So a volume form on M is an element of the following set. Okay, let me go to the other board. Let me vol M, and okay, so this is subset in direct product over alpha of the corresponding sections. So I take some element in such a product such that for any alpha and beta such that intersection of U alpha and beta is not empty, well, we have this condition that a restriction of U alpha intersect U beta from U alpha to intersection of F alpha equals up to multiplication by Berezinian of J phi alpha beta restriction of U alpha intersection with U beta. Well, we restrict from U beta F beta. Also, this Berezinian, maybe I have to pull it back. Maybe I have to pull it back to. So far it's on the chart, right? Because, well, this is transition from chart to chart. So maybe I have to pull it back by phi alpha inverse or something like that. Right, my phi alpha beta, I didn't introduce this notation, well, but it's clear what I mean. Phi alpha beta is phi beta inverse phi alpha, right? Well, actually, maybe I don't even, so maybe I need the following. So my my U alpha is an open subset inside M, right? And phi alpha. So we need to agree from where to where phi alpha goes. Well, let's say it's from U alpha to some open subset in K. Well, K. Mn, where Mn is superdimension of M, right? Then, well, yes. Then indeed, this is a function on Kmn, but I need a function on U, so that's why I need to pull back. So maybe my F phi alpha beta should be not this one. If I'm choosing this, no, okay, so it goes from M back to M. So no, it's okay. I don't have to pull it back. Yeah, I think it's like that. So it's a pull back from M to M. So still function on M. Well, anyway, so there's that's how we attempt to formulate it, and then we can integrate over volume forms. So if omega is my volume form, right, then integral over m of omega would be just sum over alpha psi alpha f alpha well dx alpha d theta alpha, right? Well, these are coordinates on my and so also I need to put integral over u alpha mn here. Well, psi alpha is of course partition of unity. Corresponding to the cover u alpha. Okay. So hopefully this all makes sense. So this is an attempt to go from local to global using our result about change of variables in Berzelian. Okay. Well, and then one might prove that, well, I chose, so I'm not going to do that, but the proof should be standard, right? So it doesn't depend on the choice of charts or on the choice of atlas, right? So it's given by making atlas as like finer, right? The standard like an usual differential geometry proof. В обычном. Сейчас, ну что вы хотите, чтобы сумма там пулбеков еще в единицу? Сейчас, ну если, ну мы хотим, чтобы они были сечениями пучка обычного, как дифференциального, ну как нашего m как дифференциального. Значит, сейчас, ну у нас все-таки есть в наших сечениях, она там, ну, локально, там на U, это обычные функции на, ну, собственно, там на R там, или на K, да, вот это. При другой карте. Да, вы говорите, что окей, у меня, если я возьму пси, начну в другую карту переходить, они там начнут быть ни разу необычными. Ну да. А не гладком. наверное, и. Ну да, ну в комплексном, по крайней мере, можно там свести к вещественному и брать разбиение единицы. Да, но... Ну да, но здесь действительно можно как бы отмахаться так, что ну давайте воспользуемся этой большой теоремой там и скажем, что все-таки можем домножать на функции. Но тут действительно сейчас. Сейчас, если нам требовать пси-альфа, значит, нам тогда нужно думать, что такое разбиение единицы в супер смысле. Ну, единица у нас вполне себе есть, как функция. Правильно? То есть, если у меня... Ну, константа, они как бы есть константа. Не, ну если нет, ну pullback константа это константа, так что вообще без всяких теорем. Вот, так что единицы там вполне себе есть. Ну как? То есть действительно, если я перейду в другую карту, то она, может быть, и перестанет быть, значит, пси-альфа перестанут быть обычными функциями. Но как бы разбиением единицы быть не перестанут. Вот, ну действительно, значит, видимо, мне не надо от них требовать, чтобы они были обычными функциями, а чтобы были как бы сечениями пучка, который структурный пучок для супер, вот, но при этом разбивали единицу. Да. Угу. Хорошо. Right. Okay. So then I wanted to discuss interesting effect here, which does not appear in usual differential geometry, which is okay. So then we can go on and try to see if we have like a Stokes, for example, theorem. But for Stokes theorem, you need integration. Well, you need manifolds with boundaries, right? Well, here you also can introduce them. It's not a big deal, I guess. So what so super manifold with boundaries. Well, I also would like to have some like local model, right? So I need some U. So suppose U is open subset of HM. Well, HM is our half of space, as usual, right? Then we need, well, structure sheaf, but I think it does not harm if we just define it like this. Well, maybe, well, like this. Tensor, well, R theta 1, blah, 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 theta n minus. well, we have notion of smooth functions on U. Why not? Why we just do the same thing as we did before, right? And then we just allow in in Atlas some of chars to be to half space. That's it, right? Just in Atlas allow some chars to map to half space. And okay, we can try to develop a theory like that, but here we have a surprise. The surprise is that actually then integration becomes dependent on a choice of chars. So integration becomes, well, dependent on the choice of chars. And there is a standard example here which even has a name. It's called Rudakov example. It's very simple. So I thought, why not we just look at it? Rudakov example. Let me consider well, this manifold with boundaries, well, with of super dimension 1, 2. All right. Well, clear what it is, right? As a differential manifold, just this interval, but well, we have two variables which are odd in the each local section. All right. Then let me consider two coordinate systems here. The first one is just usual x, theta 1, theta 2, where x is coordinate on the interval. And the second one, instead of x, I will take y, which is x plus theta 1, theta 2. Well, this is actually goes back to our working example where we looked at morphisms between manifolds, how they can work. So it's an interesting, like the most basic interesting case. So and then the odd variables, they're the same. All right. So then let me take f of x, which is just the usual even function, c infinity of 0, 1. Let me try to integrate. So integrate, well, I can now write integral from 0 to 1, right? If I take, if I integrate in coordinates, well, y and thetas. So f of y, dy, d theta 1, d theta 2. Well, I need to look at the top component here, which is 0, and this is just 0. according to our, no, it should be analog of our definition without boundaries, right? But okay, let me try to pull it back to the other chart. Then I will have what? Integral from 0 to 1. Again, the transformation just usual is just identity, so from 0 to 1. Then I will have f of x plus theta 1, theta 2. D, and then, well, actually Berezinian here is 1. So one might think that maybe something will be compensated by Berezinian. Well, let's just look. So Berezinian, so I need dy over d. So I will have 1, 1 here, something here, and zeros. And here I have dy over dx, which is just 1 again. So it's unipotent matrix, I would say. And Berezinian of this is just 1. And then I need to, what? I need dx, d theta 1, d theta 2. Okay, in this one we need to change variable, and we know how to do that. So it will be, so I just continue. So this equals 2. So it should be integral from 0 to 1, f of x, right, plus what, f prime of x, and here times theta 1, theta 2, right? dx, d theta 1, d theta 2. And, well, this term is gone, right? And this term is just integral from 0 to 1 of f prime of x dx. So it's just f of 1 minus f of 0. So now it's not 0. Just because of this term. And by the way, like maybe it's somewhere here when we were proving. Not, I don't think so. So in our first case that we were proving today, we also had such thing that was 0 because we didn't have boundaries. Now we do have boundaries, and the situation changes. So there is some problem here. Solution to the problem is that you have to change the notion of supermanifold with boundaries. It's not as easy as this, because like the notion of supermanifold actually should, well, boundary is super submanifold, and this carries more information actually. And here we're choosing this information in these two cases. So that's the explanation in words. So let me write something. So actually, so explanation. So there exists different super submanifold of 0, 1, 1, 2, such that the corresponding corresponding differential manifold, underlying differential manifold is the boundary of this, which is 2 points, right? 0 and 1. So actually, you can have two different. Submanifold. We didn't discuss it, right? But even just usual submanifold, it's not. It should be some discussion what we mean by that. Well, if the one of the more relaxed notions is immersed submanifold. So it means that I have immersion, which is injective. So we can just mimic it here, right? The immersion, it's clear what it means because we have differential. Differential may be isomorphism, right? Maybe injective. So injective differential and the corresponding map of topological spaces is injective, right? And so therefore I can actually have two maps. So going back to Rodakov example, right? I can think of two immersions of 2 points, right? Into 0, 1, 1, 2. But actually, these are 2 points. They are 0, 2, 0, 2 points, right? So this is a point with 2 odd dimensions, right? So the first one being, phi 1 tilde is the same as phi 2 tilde, obviously. But then, but pullbacks are different. So pullback phi 1 star of f is just takes, phi 1 star just takes f and gives me, so it should give me 2 numbers. Numbers or 2 polynomials in thetas, theta 1, theta 2. In this case, these are just numbers, f of 0, f of 1. Just yes. And actually I can take, and f2 star, it just takes f and gives me actually f, this I write for f from C infinity of 0, 1. Phi star on theta is just the same, right? On these things, that's what I'm writing. F prime of 0, f of 0 plus f prime of 0, theta 1, theta 2, and the same but 1, f at 1, right, plus f prime at 1, theta 1, theta 2. And so the first immersion corresponds to this coordinate system. Second immersion corresponds to this coordinate system. And well, so supermanifold with boundary. So like in general solution to this. So and there is some choice, you see, so that corresponds to different values of the integral. So supermanifold with boundary should be the following collection of data. So first, well, topological space and sheaf, right? So locally isomorphic. Either, well, as we discussed, either to U inside Rm or to N, where U is either in Rm or U is open in Hm. All right? And second, you need, so this makes this differential manifold with boundary, right? So you have corresponding topological space dx, and you need structure sheaf on this, right? So this is just supermanifold in our case. And 3, we need injective immersion from dx O d to xo, such that, well, this is of course let me maybe call it phi, such that of course phi tilde is just inclusion of the boundary, of course. And after that, then you can choose actually what's called standard. Is it called standard? Yeah, so it's called standard coordinates. So let me go here. On X. So once you have a manifold with boundary, supermanifold with boundary, there's a notion of standard coordinates. So then we can choose, well, again, this is I'm being sloppy here because this is all should be, this is statement that such a coordinate system exists. Well, such an atlas exists, right? Here, well, my goal is to, you know, just to touch this because this is an interesting, I think, effect here. So then we can choose standard coordinates on X. What are those? So that is coordinates x, I, theta, j, so that phi star of xi, well, x1 is 0. Okay. Well, x1 is the coordinate that looks outwards. Well, standard coordinates, well, so that, well, around, so this is around the boundary point, of course, right? I mean, so standard coordinates around any boundary point. And x1 is the what divide. So the x1 is coordinate that I choose to divide my half space into halves, right? And it should, so outwards direction is the positive direction for x1. Then if I require, so statement is that if I have manifold with boundaries, I can choose an atlas in which around any boundary point I have coordinates which behave like that. Such a atlas I choose standard atlas, and then we use standard atlas. Well, standard doesn't mean it's unique, right? There's a no, it's a class of atlases. To define integral now, right? And then the statement is that that integral does not depend on the choice of standard atlas. Okay, I'm way over time. Yes or not yes? So I should end at 10:20. Wait, 11:20, right? Okay, so sorry. Ну, да. Ну, я как бы вот здесь это попытался сказать, что фитилды — inclusion.
Да, но там могло бы быть, то есть фитилда, она же не видит вот второй.
Ну, я говорю, что что это injective immersion.
Да, то есть это имеется в
Супер смысле, да. Ну, то есть там есть еще второй блок, который должен быть невырожденный в дифференциале.
Да,
Там dx, ну, дифференциал состоит из двух блоков. Вот. Но в данном случае первый блок вообще ничего не даст. Вот, ну, например. Ну, в данном случае, да. Нет, ну и вообще в любом, да. Да, потому что у нас нечетная степень та же самая сохраняется, а четная падает. Значит, вопрос такой, мы на следующей неделе чего делаем? Ничего не делаем или встречаемся? Какие у вас? Ну давайте, потому что я медленно иду, хочется уже перескочить на какие-то представления там супералгебры там и так далее. Вот, то есть тогда в следующий раз я начну супергруппы. И, ну, я не знаю, чтобы не вносить большего беспорядка, наверное, в то же время, да? Окей? Да, давайте так. Тогда на следующей неделе просто по тому же расписанию. Да, это хороший вопрос. То есть я потихоньку собираю, но вот я надеюсь, что в течение недели там или двух. Ну их уж тоже точно не будет 3 штуки, но то есть там много чего интересного можно там про супер группы вот. Здесь, ну я не знаю, как-то вот не накапливается чего-то такого, чтобы не жалко вас заставлять было